Hello.
Hello, audience. Hello, Robert.
Hi, Klaus. Hi, audience. Yeah. Welcome to this episode of Fun with RELUX. Today it's about glare, about in special UGR.
Yes, unified glare rating.
Exactly.
We haven't an episode with glare rating.
We had one
some months ago, but it was more a little bit general about general glare rating routines, methods. But today our topic will be a little bit more specialized for the UGR.
Yeah, there is a lot of glaring ratings, glaring calculation options out there, especially for outdoor, I have to say. And yeah, we have covered it. I guess we covered it almost all, at least the common ways. There is a lot of more which is not common, which is not really in use, which is academic. But we covered it all. And today it's just about UGR, because this is one, the most important one for indoor lighting. And yeah, we will have today a kind of presentation like in the last episode. So we will have some theory about UGR, what it's about, how to calculate, how to use this tool UGR. And in the second part, we will also have some RELUX desktop open and show you how to get UGR values out of RELUX desktop today. Yeah, so this is all, and let's start with the slides. So the first slide, no, it's not active. I need to focus this. Yeah, first is about the, let's say, what it's about. What is glaring? So we deal in UGR just with direct glares. There's a lot of different glare options, methods to glare you. There's direct glare, of course. So this means what is coming direct from the lumina into your eyes. As direct glare, there's indirect glare about one surface which is reflecting and so on. Sorry. I forgot to switch on the screen sharing. Easy to fix. So now you can see the first slide. You do not miss anything. So this is the first slide. Is about glare in general. So glare, there's a lot of different glare options, and here we can see a sample of a direct glare out of luminas into your impression of the scene. And direct glare means a direct harm of light into your eyes from a lumina, not from sun, not from daylight. For daylight, there are different methods, DGP, for example, which is also included in RELUX. But UGR is just about artificial light, indoor. Mostly, it's also possible to have it outdoor, but we will see some restrictions on this. And yeah, it's the direct part which prevents you from seeing something else or have in good view on the scene by being disabled of glare. Okay, so I guess it's clear what's about. So I just again need to switch the slide. Okay, this is the second slide, and here it's about what is UGR in general. So UGR, it's unified glare rating. Unified means, okay, or everybody using the same method to rate glare. There's also a new expression called RUG. You will probably have seen it in RELUX desktop. We changed the term UGR to RUG. There's a CIE standard. I guess it was 017. I'm not sure about. I have to check. There's a CIE standard, which one ICE standard? I'm not sure. There's a standard and global standard, which reorganizate, which changes the symbols, the formula signs. Yeah, and a lot of R's in the end going to the first part. So out of UGR, we have now RUG. It's the same. It's the same value in a way. It's just another expression, and it's now a ratio of unified glare. You have seen it also in other lighting formulas, symbols. This is changing, but it's okay. It's now in global inline how to call it, but we still call it the UGR method. So the method, how to calculate it, the complete methodology is still UGR. You can also use the term UGR. It's not forbidden. It's just the value, the expression of the value. This is in RUG value now, the number, which is the result. So do not be confused. It's just the same, just another arrangement of letters. Okay. Everything about unified Clair rating about the UGR is in the CIE 117 from 1995. So this is the standard which has the formula, which defines the UGR value, which also defines the table method. Everything is in this relatively big CIE standard, and yeah, and you find this formula in the standard is the famous UGR formula. And it's, of course, it's kind of complex, so it's not a formula where you can just bring out your pocket calculator and have the number ready. The formula consists out of all the single light outputs and the background luminous, and this is something which you but at least you need to understand the parts of the formula. Yeah, as I said, it's impossible to calculate it by pocket calculator. You can use Excel, but of course it's most convenient if you use RELUX to calculate UGR values. We will see later. But it's important for a lighting designer to at least understand the values, the parts of the formula, which helps you to identify Clair and which helps you to know what you're doing by putting luminance into a scene, that you have in feeling what you do in terms of claring. And the formula is really helpful because we have here the luminance of the lumina, which is yellow. So the luminance of the lumina, this means what comes out of light, out of the area, out of the lumina. This is the yellow part, so the active part of the lumina, and the magenta part here is the background luminance. So the luminance of everything which is not lumina in a way. And here we see this is in contrast. So we have the ratio of the lumina itself to the background. So this is Clair. Clair is nothing else as contrast, as a difference between an active part and the background part. Nothing more. And this is crystal clear if you think about. So claring is just in high contrast. Everything. If everything is quite bright, then you have not Clair. Of course, you adapt just to another level, and everything is the same ratio. Clair comes to place if we have a difference of luminances in our scene. The blue part means this is the solid angle, and then positioning index P and omega for the solid angle. These are parts which determines your relation in your geometric location to the lumina, because this is also an impact on how much area surface you can see from the lumina. So this has also an impact into it. And I also put in the formula for luminance in general. So this is intensity divided by area. And this means if you keep this in mind, that you have an lumina with a big area. So the area is down in this division. This means and brighter and much more area on the lumina means less claring, which is obviously because you have then the same energy on a larger area, and this is less glary. So this is also important to understand, that you have an impact with the size of the lumina area. Of course, the manufacturer can control it, but you can choose a lumina with a bigger output, then you have less glare impact. And also important to understand is the background. So if you have an white room, and bright white room, or some wall washers in the room, so in high background, then of course you have less glaring to the luminas, because you have then less contrast to the luminas. So and the vice versa. So if you have a really dark room and you put in a single lumina which is quite bright, then you have a glare effect on it. So this is something which you have to have in mind if you design a room or placing luminas. Then this is important to have this feeling what you are doing and in the arrangements. And the last point of the slide, the UGR value is just defined between 10 and 30. Mathematically, you can have different values, higher values, lower values, but the definition out of CIE 117 is just in between 10 and 30. So this is the limitation. Okay, next slide to illustrate you the situation of the formula. So I tried here to put the formula into a room that you can have an feeling what is the consisting parts of the formula. And here we have a nice RELUX scene. And the first point is we have this luminance of the lumina itself. So this is the surface which is active, which is bright. The light comes out of this area. And again, the size of this area has an impact on it. And also, of course, the intensity. So how many luminous flux you have in different directions, of course. So this is the one part which is glary in a way. The second part, in contrast to this, is the background luminance. And the background luminance is also, as you can imagine, hard to calculate. It's not easy, or there's a lot of interpretation what is really going into count of this background luminance. And also, by the way, this is the background luminance is also the part where we have different values for UGR in different applications, because everybody has some slight different ways to calculate this background luminance. And the last part is the orientation of the observer to the lumina. So this is the blue part of the formula. This is where we are located in different locations, different viewing angles. You have different UGR values, different glare levels, as you speak. So this is, I guess, quite helpful. Again, contrast matters for UGR, not just the lumina, not just the room, both in combination. So this is the UGR, let's say, calculation method for a free locatable observer with free any luminas you can put into the room. And there's another scenario for UGR. This is the table method. Table method is something special out of the UGR. It's some kind of a worst case glare scenario. So this should help you with a table to identify luminas and application of the luminas in terms of glare, without having this expensive calculation of the UGR value. Because if you remember 1995, it was hard to find computer applications who could calculate this. So the idea was, okay, let's define a table, and with the table, you as a Latin designer can identify everything in your situation and have UGR value ready. So table methods were in general quite popular in the 80s and 90s, and nowadays we have more and more calculation applications which can also do it just on the side. Okay, the table method. This again in worst case scenario. This means we have a room, a standard room, and we populate as much as luminas which is possible into it. And for the table method, it's even more than possible physically, mechanically. So we have here a sample of an, I guess it's 12 by 6 meter room, and this have 561 lumina in it, which is overlapping because they are not fit mechanically into this. But the table method forces this amount of luminas, and I show you in a couple of seconds why we have to fill up so many luminas specifically on this room. And we have two orientations for the table. The table has an crosswise and an endwise section. So two big columns. One column is for the crosswise and one column is for endwise. And this has nothing to do with the room orientation at all. This is more about the lumina positioning. So crosswise means you have to, or this observer looks into the lumina from the side, and the endwise look the lumina from the length parts of it, as here illustrated. So if we flip the luminas in 90 degrees, also endwise, crosswise swapped together with the lumina. So it's nothing to do with the room, it's more about the lumina orientation. And this makes totally sense in terms of glaring. So if you check a lumina from the side, it's indifferent as you check it on the endwise side. So this is, especially if you think about the old louver luminas, this has a different impact if you check it from the side or from the end part. Okay, and how we can calculate this, and this comes to the spacing to high ratio. I'm sure if you have checked in table, you have maybe wonder why we have the spacing to high ratio of 0.25. This is something out of the CRE 117, which defines the spacing to high ratio to have 0.25. And this is just the division or the ratio of the luminar spacing, so the distance between the luminars and the height between the observer and the luminar height, so the mounting area. So the difference, you can find it here in this small sketch. The observer position in the sitting position, it's 1.2 meters in general, and in the standing position we're using 1.7 meters for this. And h, the height, is so the observer side height and the luminar area. So, and if you calculate the spacing, the S, by the spacing to height ratio multiplied by this H, by this height, you end up by a distance of the luminars by, in this case here, by 0.375 meters. And this, if you have a luminar which is 1.5 meters length, then we have an overlapping of this. But this is here down to the single light outputs of a photometric file. So. And that's why we have such many luminars. It's about the spacing to height ratio. In the UK, sometimes in the older days, there were also spacing to height ratios of 1. This is caused the UGR standard comes out of an older British standard. I thought the name is also something like Clare ratio. And they're having used a spacing to height of 1. And by creating the 117, that was the base for this, but they found, okay, we need a more worst case scenario as in the past, and so the CRE 117 defines it to 0.25. In our application, we can switch also the spacing to height to 1, but this is just for legacy projects. This have nothing in common with the normal standards today. So this is something more legacy. So please do not use spacing to height to 1. Please use spacing to height of 0.25, because this is the standard. This is CRE 117, and yeah, and this is something everybody should use today, and to be in line with the standard. 1 is just a legacy standard which is not active anymore. Okay, then let's check the table itself. Surprise, looks like this. Potentially I've seen it before. As said, you have this big 2 columns. It's crosswise and endwise, depending on the luminar orientation. And you have on the top the reflection degrees of ceiling, walls, and floor. So we have there the standards, 70, 50, 20 for a bright, white room. And you can see here on the table, the brighter the room reflection is, the less you have UGR values. The darker the room is, the more worse the UGR values get. So, and this is something which you need to also have an account. So if you have a dark room, then you have not so good UGR values. And it's also possible to have this UGR values not just for this 5 standards of room reflections. It's also possible to calculate these tables with any other reflection degrees, which we do in RELUX. And so these are the columns, and then you have the rows of this table, and this is just room dimensions. But room dimensions not just by meter or by ratios. No, we have here also this H. So the height between observer eye plane and the luminar mounting plane. And this is divided by H. So, and there's not a real written standard, but let's say a standard in usage, which is 4H, 8H. There's no written standard to force you to use 4H, 8H. But if there is no room involved in the situation, then this is some kind of a standard room size which is referred to a lot of data sheets. So if you found just 1 UGR value to a luminar, then this means this is potentially 70, 50, 20 and 4H, 8H for the room orientation. I cannot tell why in particular why it's 4H, 8H. It's maybe in the middle of this. Maybe it's the orientation which is perfectly harmonized. There is a harmonization and golden cut and so on. I don't know. And then we have two values. And if you have a symmetrical lumina, then this both values crosswise endwise are the same. But if you have an axis symmetrical lumina, as we have it here, then you have different values for this both orientations. And you also can tell how much the lumina is symmetrical by checking the UGR table, for example. And down below, we can see the spacing to height ratio with 0.25, which is the standard. Yeah, this is the table. And the 12464-1 refers to the table values. The old one, the new one, so both, all the 12464 standards in the history refers to the table, not to the calculated value. The table is just more, let's say, secured. There are more studies about the table. There's less information on the calculation method. And on the calculation method, you also need to know precisely the observers. And the table is neutral from observer, or it's just on the wall looking into the room. So in general worst case scenario, which is for the authors of the 12464, the more reliable part. So table counts. And in Windows Desktop, if you check the results of your calculation, and there's also a point of UGR, and on this UGR result is the table behind, but table with the real reflection decrease of the room and with the real room dimensions. But this both real in the table, the value of the table out of room dimensions and reflection. And this is according to 12464. Yeah, so this is, and we will see it in a couple of seconds, but I have a last slide, and this is about the limitations of this, because if you have in mind how to calculate it, what is behind, then you sure will find a lot of limitations by yourself. But here I have in the presentation. Limitation number one is you can just have for a UGR table one lumina and not multiple luminas. And in the current, in the new 12464-1, there is a hint how to deal with the situation if you have several luminas in a room, which can happen, of course, happens quite often. Then it's quite simple. The worst UGR value of the worst of the lumina counts, which has the worst UGR value, just the worst of it. So it's quite simple and makes absolutely sense to go in this direction. Then you can just use luminas which are populated straight. So it means not angled, not flipped, not aimed somewhere. It just must be installed straight downwards on a ceiling, including suspended ones, but mounted on a ceiling in a way. So it's not applicable for wall luminas, freestand luminas. It's just applicable for one plane of luminas on the ceiling, straight downwards. That's all. Most of the situations is this, but if you have another situation, it's not applicable. You get potentially values out of the softwares, but it's not applicable according to standard. The same for asymmetrical luminas. So if you have an asymmetrical or double asymmetrical luminas, not applicable. Also indirect luminas. By indirect luminas, of course, you're making the background luminance a bit better, which is good for UGR, but it's not going into account of the UGR value method. So this is expecting that the lumina is making a glare effect and not a background effect. Simple. Then also not applicable are luminous sealings. So if you have a sealing which is just diffused glass or plastic, large luminas, or the complete sealing as lumina, it's also not applicable. And in this situation, you don't have to deal with glare in general. So this is just not glary, which is good. So you do not need to have these UGR values if you have this situation. By the way, no UGR value means more often you have not any lumina inside, which means no value is a good value in terms of glaring. It's also applicable just for homogeneous light emitters. So the light of a lumina should come out of a homogeneous surface mathematically. It's not meant for luminas which have a lot of tiny outputs, but there is a relatively new standard. Is 3, 4, maybe 5 years ago, there was a CIE 200 32, and this standard has an adaptation factor to deal with the situation if you have multiple small outputs in lumina, like LED lenses or small reflectors. There's a standard to deal with it, but I have to say, for the standard, you need information from the manufacturers, and this is not really available today. It's more academic. There is an academic way to deal with it, but not in practice today. Then, and really also an limitation written down in CIE 117 is that it's not to use if the light output is too small, or if you have in too large distance, and you can measure it in a solid angle. So the solid angle have to have bigger than 0.0003 Stertariant, and this is for example a normal downlight 10 centimeters in 10-meter distance. So this is a solid angle of 0.0003. By the way, it's the other way. It has to be bigger than this. And yeah, so if you have a large indoor area, in hall, whatever, which is more than 7 meters. So the 7 meters is not in the CIE 117. You have just this solid angle, but 7 meters is from the practice. A lot of papers reference to the 7 meter. Up from 7 meters, you should think twice about using UGR. Yeah, but this is limited by the solid angle, which you can calculate on each lumina, on each observer. And if you have a value less than this, then it's just too far away. Okay, then of course, just rectangle rooms work with the table. So we have just this 2H or this H-related room dimensions, and this is also comes to an end. So the most of the rooms, of course, fit in this scale, but potentially have a really large hallway, and then it might not be fit into this scale table. There's also a hint of the 124641. We can just approximate one rectangle into the room. This is okay for the 12464. If you have a polygonal room, just make a bounding box of it and use it. We do the same in RELUX Desktop. We just make an approximation of the room dimensions. And if you reach an end of the table in the rows with 2H and 12H, then just stick to the last value of the table. So quite simple and works well. And it's great to have it today in the 12464 covered. Of course, there is since decades no new CIE 117, which should also handle these topics, or at least tell the user what to do if you read a limitation. And yeah, this is good to have this application standard to deal with it. And I guess it was there's one last point. Of course, only it just works for a straight line of sight of the observer, the whole thing, the whole UGR stuff. Of course, yeah, it's just limited to this observer position. If the observer looking above or looking downwards or change the side, the angle, then it's not applicable anymore. And okay, this is really a hard limitation. So it's just valid for a certain situation. So this makes it in practice to really calculate and clear for an observer limits. It's just to a certain angle of sight, not up down, just on one plane on a certain height. But of course, the table method, for example, is great to compare different luminas. Of course, this is in some kind of a standard worst case setting for all the luminas. And yeah, it's good to compare luminas with these tables. So this is solid. Good. And now let's jump into a bit of practice. So Klaus, maybe you can show us how to deal with UGR in RELUX Desktop.
Yeah, let's take a short, quick look into RELUX Desktop, and I will start here. This is a little bit too fast. We have here a standard project, which just some simple situation, and if we calculate it, so the most important thing about looking just a moment, for any reason, on this calculator, it needs a little bit, or this computer, it needs a little bit time to start
the calculation.
The calculation call for any reason at the moment. But we have here inside of the luminaire data, where you will find all the luminaires which are used in your project. You will find here the glare rating UGR value. Okay, it's already finished with the calculation. And there you will find the table as Robert has shown it before. But in RELUX, if you make a standard calculation, then you will find here on the result overview, here in this area, the UGR value documented as it is required by this profile from the 12464. And this is not a calculated, it is a calculated value, but it is interpolated. It is just checking what are the room dimension. This is in our example now 5 Ha to 6.3 Ha. And then it is looking here in this table, what is the interpolated value here out from this table. So this is what we are normally do when we try to following the standard like the 12464. And over this, we have the possibility to place manually observers. You will find them under measuring objects. There you will have some all the other measuring objects, but you have also here the observers for glare rating. And there is also the UGR observer, and we have now the possibility to place it here. And the observer is an object which can be placed and moved, rotated, similar like all other objects in RELUX. And you have the possibility, for example, the point which is explained by Robert here, you have now the possibility, by default, it is just a range from the viewing direction plus minus 15 degrees, but you can change this individually like you need it. And then we have one observer in our scene. And I also want to show you, you have also the possibility on a measuring surface, like my reference plane here, for example, under calculation, to add here a UGR table. That means in the next calculation on this, on the grid points on this measuring surfaces, which is here in a height on 1.2 meters, like we wanted for sitting people in an office, then we get the maximum UGR value on each of these calculation points. So let's make a calculation.
Crossing fingers.
Yeah, this is for any reason we have to check. So we have now the results. So the first one which I want to show is the result for the observer. This is now in graph, where we can see now that the angle which I have set it on, this plus minus 45 degrees. And now we have here, for each direction, you can choose the density of this, of how many steps they will make. And there you can check now what is the maximum in the calculation. You will see in our example, it's a little bit lower than what the table methods delivers us for this result. And also we have the possibility to take a look to this UGR table, which is calculated here on the reference plane. You will see here when you go, because I'm looking from the to the other side of my room, then you will see here at the end that the values are very low, because we will not longer see any luminaires because we are stepping to the wall. And here in this area where we have typically the observer, like we are also using for the table methods, we have a little bit similar values like in the table methods from the results. Yes, these are the points where how you can handle the UGR value in RELUX. So you have various ways for analytical things, and also for the standard, to following the standard by using this UGR table and or when you make a calculation and you check it on the result overview, and you will get the relevant value here. This is the relevant value for planning according the standard 12464.
Yeah, good. That's great.
It was so.
It's not so much. So it's not a big miracle, UGR. Yeah, but is this discussed a lot? To say on all the conferences, UGR is really discussed because it's not perfect. It's the best what we have right now. It's quite in place. So a lot of people using UGR values. Industry has adopted UGR, but it's not the end of the line if it comes to glare ratio. But let's see how it ends. What we will have in future in terms of glaring calculation, glaring values. Of course, I do not need to tell you, glaring is also something quite individually. So in UGR, 19 value means not that you are not glared. So if you are a sensitive person,
it is really personal. So that makes it for the planning really hard to say so.
But it's just in comparison. So you can compare luminas. You can also compare luminas in a room situation by this observer method or by the table method between luminas. So this is a nice tool for designers to deal with glare, but it's not really the total last value you get in order to say, okay, this is now glaring this person or not. This is just in part of it, just in the direction of a solution.
Okay, time is growing up.
We go for questions.
We'll take a look if there are any questions and.
Okay, I see. Okay, UGR value 19.5 still consider UGR lower 19. Good question. It's about rounding. If you can round it down, yes, you can do. Yeah, it's absolutely possible that you can round it down. This is also heavy in discussion. What you should do, or where is the rounding. There's also a lot of different rounding methods coming from a software point of view. It's also not so easy to do, but yeah, you can consider. But then just take away the last digit and not put the digit in, because maybe another is rounding it different, and potentially you have to discuss the rounding method. But in the standard, it's just 2 digits without any point in the standard. So it's just about 19. So it's not 19.0. This is something which the standardization has done with uniformity. There was then a uniformity of 0.60, for example, and not 0.6 anymore, in order to deal with this rounding. But for UGR, it's 19 and not 19.0. Otherwise, it was not possible to round it down. Good. Next question is about
why the UGR values indicates on the table and on the room method are different when we are using the same reference point. This is related because for the table method there is used a standard room with the luminaires filled in a different way as we have it in a real situation. But the standard is referring this standard rooms with the space to height ratio filled to the luminaires, not with the real situation. If you rebuild the standard, the room which is also used for the table method, then you will have comparable values or close to the same values.
Yeah, and also you need to have the same spots with the same direction. It's also not so easy if you change the spots, and depending on the LDC of the luminaire, it can be quite sharp. And then moving 10 centimeters the observers, then you have different values.
Yeah,
it's not homogeneous in a way. So it's really about position and of course background illumination. This can be different.
If the shape of the room is not regular, results from the software could be considered valid. That is what, when we take a look to the 12464, they say if we are working with polygonal rooms or not a standard rectangle room, we will use the
bounding box,
a kind of bounding box from this room.
Approximation to a rectangle. Yeah.
So that's what the standard says.
Yeah. The 12464 tells us that it's possible or should be done if the room is not rectangle, which is often the case, of course. Then, yeah, again, is UGR 19.5 the same as 19? Depending on your rounding method, it could be also 20 if you round it up. So it's about the rounding and what you communicate, what you kind of a rounding method you have. If you round, I am missing the English words for this. If you're rounding commercially, then it's 20. If you're rounding scientifically, then this depending on the next digit behind the 5, which we can't see here. So not so easy to tell, but it's also from a practice point of view, this is the same as you find about 499 lux versus 500 lux. So it's quite the same, and there's not a hard border to say, okay, now you're valid, now you're invalid. This is and there's a lot of options to tweak UGR. So for example, room reflection degrees, which mostly not defined. You can define your own and say, okay, I calculated the room with 85% for the ceiling. And then you will get, then you have better UGR values. And then you say, yeah, you do not tell me the reflection degree of the ceiling. I have to find my own one and then using a higher one, for example.
Okay, so which UGR value should we submit for the design? As we told before, in the standard, it only refers to the value. So this we need an UGR value smaller than 90, for example, comes from the 12464. And that means you must smaller than 19 in the table methods. The observer also is more important when you want to make some analytical things. But it is not so important if you then have a smaller this 19 point anything, because they explicitly say it is not these limit values are created for this table methods and not for the observer methods. Also, it is recommendable from the German ZVEE. There is a real good paper who goes a little bit deeper in about the limitations of the ZVEE and the compromises or in the handling of all these variants. It is also available in English
and for free.
So that you can download it and go a little bit deeper into study it.
ZVEE, yeah, ZVEE in English. Hard to say. Yeah, ZVEE. And UGR. Just Google it, you will find it, download it for free. A lot of details from a really good professor in Ilmenau, which was also deeply into UGR studies. Yeah.
To try to give a little bit a workbook for how to handle all these questions in which you are stepping in when you run into this.
The standard 12464 defines UGR 19. Why does RELUX mentions a 90.x, so a digit after the point values? So with digit behind the dots as outcome, this might result in discussions with customers. It could be even more worse, Mark, by putting more digits in it. But as a designer, you want maybe to have the feeling, okay, is it maybe sharp behind this 19? If you have 19.8 or 19.2, this is a difference. And as designer, it's good to have more insight into this value. But maybe we should add some rounding method. We have it on elimination values and the system how to round the values.
It's a big discussion how to round which value, how to round which value.
How many digits?
And how many digits? I'm so lucky about that. In the street lighting, there is in the standard there's now written you have to round this value in this way, this value in this way. We missed this a little bit in the other things, but maybe it would make sense that we make an option that you can switch off the rounding or that you can control the rounding also for the UGR table. But in general, it is a little bit that you can control the difference between the luminaires, and you will see which luminaire is a little bit better or is a little bit worse than the other one.
Yeah.
Then you really fast need this at least one digit at the end.
it's for you as a designer, it is great to know the digit behind it in comparison of different products for your design. But in order to communication to the client, of course, it would be nice to limit it to 1 digit. So, but
okay,
at the moment, it's it's one value and not for you and for your clients. But we think about an option.
We will put it on our feature list and think about an option about this. Okay.
Yeah, there was one question about 4H, 8H, just roughly. This is not a written standard. This is 4H, 8H reference, which the industry applies a lot to rate luminaires without having a room situation. So if you have not any room, the industry is using 4H, 8H. If they are nice, they put it on the datasheet that this UGR values depending on 4H, 8H with 70, 50, 20 room reflection. If not, if it's short, then you have just one value, potentially the worst one of length and cross, and it's 4H, 8H mostly. So this you can double check by just calling the guy behind the datasheet or the manufacturer what is about this UGR value for which situation, and they have to tell you. Yeah. Okay.
Oh, sorry.
Then we
are finished.
We are finished.
And
thanks for your questions.
Just an outlook for the next episode of Fundus RELUX. It was on
the 25th of July. Same time slot. It's also on Thursday, and the topic is
luminaire blazing.
Okay. Positioning of luminaires.
Positioning of luminaires. How to place luminaires. What features we have.
And tools to place luminaires.
It's a little bit more practical than this.
But like not less complex as you.
Not less complex, but not so theoretically as our topic today.
Yeah.
Okay. Thank you. Have a good time, and see you next time. Bye.
Bye.